Hello and welcome to Kubernetes Edge Day. My name is Prasenjit Singh. I'm the Director of Cloud and DevOps Practice at Starzplay Dubai, where we are reinventing video streaming with state-of-art engineering on the cloud and the edge across 20 plus countries worldwide. Today, I'll talk to you about DevOps on the edge. Essentially, we'll touch upon DevOps tools and tailored practices that will define the journey to edge computing and will assess where we stand today in terms of edge capabilities. Well, I must tell you, these are really exciting times and we are heading towards a disruption. And I'm saying this because three contemporary technologies are on course to define the next decade. One, containers, two, machine learning, and three, 5G networks. Containers provide portability, 5G provides speed and bandwidth, while machine learning provides insight. Just imagine what power these three bring together, and when working together, these have diverse applications, right from auto-driven cars to medical life-saving equipments, video streaming, collaborative gaming, space exploration, and the list goes on. In fact, this combination paves the way for a massive disruption which we call edge computing. This will transform how enterprises run applications and services today. Core to this transformation is the ability of deploying these applications to edge locations. Now, before we go on and understand deployments, let's understand edge. Now, what is edge? For the uninitiated, edge computing is distributed computing architecture that moves applications as close as possible to the user base, and edge computing moves IT resources closer to where data is produced and consumed. So the traffic from devices is processed and analyzed in near real time. Unlike the cloud, deploying closer to the edge of the network enhances customer experiences by reducing latency and network costs. Well, it makes technology reliable enough to handle critical applications like remote patient monitoring by hospitals, content delivery for streaming providers, energy management in power grids, and of course autonomous vehicles. Now, all this sounds cool and futuristic, but what are the challenges? Let's have a look. Well, edge is a crowded place, smaller footprint but more numbers. It is distributed across thousands of applications with limited space, limited cooling power, scarce computing resources, and architecture heterogeneity. The edge is made of different nodes, various sizes, vendors, technologies, large, small PNFs like Criminal, Greengrass, then you have your Azure Edge, AWS Outposts, and so on. So this requires proper and a flexible and lightweight orchestration tool. So yes, the first challenge is orchestration. Then we have scalability challenges. Edge nodes are very small, availability of resources for application is not guaranteed, and then because of the numbers and heterogeneity, as I said, the visibility is another blocker. So you need good lightweight monitoring tools for getting insights into your devices and to track and solve your problems. Adding to that, when we keep running edge nodes, we keep generating data. So edge locations do not have ample resources to store this data, so there needs to be a proper policy to either recycle or archive this data. That becomes a challenge on the edge actually. And finally, there's a challenge of security because data at edge is highly distributed, and this means an enlarged attack surface and at the same time less visibility of what's going on, and all that can be disastrous. So how is all this tackled? What is the answer? I believe DevOps is the answer. DevOps practices provide a framework for delivering consistent and reliable software with changes done as fast as possible. Microservices, containers, orchestrators like Kubernetes and CI/CD pipelines solve the problem of heterogeneity and deployments. So DevOps allows to build infrastructure as code on the edge using tools like Terraform, and you can use tools like Ansible to manage configurations on infra. You can even use Terraform for configuring software-defined networks, and Ansible playbooks are used to run lifecycle operations like archiving and backing up data back to the cloud or object stores. So this way, DevOps is something that solves all these challenges we face at the edge. Now the point is, how? The answer is DevOps practices ensures applications are built for open containers that can be securely deployed, tested, run, managed on multiple devices, and with services executed from multiple private and public clouds. Also, lightweight monitoring probes enable real-time telemetry of the services. So DevOps provides the guardrails to your developers early in the development cycle so that they can stay agile without inadvertently compromising the security. Checks can be integrated in the CI/CD pipeline to prevent security issues from making into the edge environment, and you can also put up alerts so that your developer can be alerted to the issues and the needs, like issues that need remediation actions before it's too late. So the security shift left approach is a good way and a good practice in DevOps that reduces cyber risk and also reduces cost. So that is how DevOps practices solve the problems of orchestration, security, scalability, monitoring, and data lifecycle. Well, now, how is all this done? How is DevOps tailored for the edge? Well, custom DevOps for the edge requires a few tweaks. You can either go with public cloud offerings or use open source. Depends upon your choice and scale. If you go open source, first use GitOps. Now, GitOps or JITOps is a core idea of using Git repository that always contains declarative description of infrastructure currently desired in the production environment and an automated process to make the production environment match the described state in the repository. So that will set up CI/CD on the top of declarative infrastructure, so you can stop scripting and start shipping your code. So GitLab and GitHub are good enough for doing or practicing GitOps. Now, the second thing is to use declarative pipeline and CI/CD. You can use tools like Drone to build the image, launch tests, and deploy on different environments. It's a lightweight tool and does the job. Well, if you have a hybrid infra where you can, like you have some servers on the cloud, then you can afford Jenkins because it's Java and bit heavyweight. So you can use that too, but I would recommend Drone because it's lightweight and you can run that on the edge as well. Well, you can use Rancher to manage catalog Helm charts, and you can use it for monitoring project access rights, for governance of the Kubernetes nodes. You can use Jitty to manage the sources of applications and Helm charts for versioning. You can make your own private Docker repository using an open source tool called Harbor. All these are very lightweight tools and specially designed for edge. You can use that too if you're going open source. If you're going closed source, you can use tools from IBM, Red Hat, very good tools as well for this purpose. And even public clouds like Azure and AWS have their offerings. Well, coming back, for the orchestrator, obviously you have to use Kubernetes because that's the best out there for Docker containers or containers as a whole, and use a lightweight version like K3s. So that is going to help a lot when we are talking about our environments in the edge. Well, number 5, you can use monitoring tools that are lightweight. So one of them is NetData, and you can use a combination of Prometheus and Grafana as well. They are also very lightweight, and Prometheus can be used to probe the data and Grafana for the display. And finally, you should actually shift left your security gates. In most simple terms, shift left security is moving security to the earliest possible point in the development process, so that in this case it will be incorporated in your pipelines, and even before your container is baked, these test cases will run and find out security loopholes and will not release your application version into the edge. So that will prevent or save you from security vulnerabilities. This, along with other peripheral security layers, will make edge apps robust. So what are the takeaways? Because edge has a smaller footprint, number 1, you should use lean tools, lightweight, stripped down, fat-free tools. Number 2, shift left, introduce security check in the pipeline itself, as I said some time ago. And of course, practice DevOps principles of continuous integration, continuous delivery, continuous feedback. So that helps you keep things in check. And finally, use Kubernetes, as that makes orchestration seems like a breeze. And because you are talking about the edge, Here, a car is not a car, it's a worker node of a Kubernetes cluster. So that is all from me today. Stay connected for upcoming sessions at Kubernetes Edge. Thank you.